All right, so I'm going to do the SMT study guide. I think I'm going to do it in 2 pieces because it might get kind of long. These were the notes at some point I put up. So for problems 1 through 5, the ideas would be that vertical angles are congruent, linear pairs equal 180, and then you had all the angle relationships. Corresponding is in the same relative position. Alternate interior is inside the parallel lines, but on the alternate sides of the transversal. Alternate exterior of the parallel lines, alternating sides, and then same side. The only one of those that is equal to 180 is the same side interior. Then these 5 problems had isosceles triangles, were 2 congruent sides that gives you 2 congruent bases, and then equilateral triangles, all 3 congruent sides, which would make all 3 angles 60 degrees. So let's look at the problems. Okay, number 1, we set this up, that y plus 23 and 63, let me redraw this. So these 2 angles are vertical angles, therefore they're congruent. So we would say y plus 23 equals 63 and solve that. And then we could look here and say that these 2 angles are a linear pair, so they equal 180. So we're going to set that equation up and solve it. Okay. So on our angle relationships again, corresponding is in the same relative spot. So top left could be top right, bottom left, bottom right. If I took these 4 angles and put them on top of here, they would be in the same position. So corresponding is same position. Alternate interior, again, alternating the transversal inside of the parallel lines. So inside. Exterior is going to be on the outside, alternating the transversal. Same side interior, like that. And those are going to be equal to 180. And vertical angles are across from each other. Vertical angle out of all of these is the only one that doesn't really involve having a transversal, but it's just we learned that they're across like this. And those are congruent. So using that to solve a problem, let's take a look here. When I worked through this, I first figured out that we could do it in any order. I'm going to look here and here. Those are alternate interior, so they're going to be congruent. And then I said this angle and these 2 angles form corresponding angles, so they would have to be equal to each other. So I had 139 minus 47, and that gets you this guy at 92. Then I saw that this was vertical, so that would be also 92, and then you're left with a linear pair. So 180 minus 92 minus 47 got you 41. Okay, for here, 5x and 145 don't have a particular relationship, so I got to think about, well, 145 is corresponding to here, and that then would give me 180 degrees, linear pair. So 5x plus 145 equals 180. Solve that. Okay, so now here we have the isosceles. This had 2, it told you these were congruent. Therefore, we have base angles congruent. Therefore, x would be 72 and y would be 36. How did I get 36? I took all of it is 180. That's triangle sum. Subtract the 2 that I know, 72 and 72, and I get what's leftovers, 36. So this one over here is a little different because they gave you, they didn't give you the base angle. So I'm going to take away 30, leaves me 150 degrees. Divide that in half because I need to split that up between these two angles. That's a total of 150 divided in half. The side lengths right here, 6 and x equals 6, because they're congruent. Isosceles, pretty straightforward. Equilateral, all three sides equal 10, and so y plus 3 would equal 10, giving y equals 7. This is the one where I said people tend to get confused and try to combine sides with angles. So sides, you only want to deal with sides if you're dealing with a side. 3x plus 8 is congruent to 4x minus 1. Solve that. And then all the angles are 60, so we can say that 2y equals 60 and y equals 30. Okay, we went through this one in class. When we have a midsegment, the midsegment is half as big as the side opposite it. So it takes 2 of the small ones to equal 1 of the big one. And it just depends on what your problem looks like, if you want to double the small one or if you want to take half of the big one. In this case, it's probably easier to double the small one. So 2 of the small one, 2 times x plus 4 equals 4x minus 2. Solve that out. And then what you also have is congruent side pieces, because it splits this in half. So 4y equals 6y minus 1. So you get that equation set up. Okay, with triangles, and we said that in order to be a triangle, the two smallest sides have to be greater than the largest side. So add them up, 6 plus 8 is 14. That's greater than 15, so that would not be a triangle. And as far as the range of possible values, so if you subtract the two numbers, you get the smallest. If you add the two numbers, you get the largest possible. So the third side would be between the smallest and the largest possible, the largest and possible. So subtract them to get your small n, add them to get your large n. And it's important that it's just equal, not equal to. Okay, it can't be equal to. All right, the 5 postulates. Hypotenuse leg, we'll go over these real quick and I'll rewrite it just to draw your attention to it. The question is, are they congruent? Well, we've got a hypotenuse, that means a right angle, and then its hypotenuse, and it's got one other side, so that meets the hypotenuse leg criteria. Here you've got a shared side, so that gives you angle, side angle. You've got a vertical angle, so that gives you side angle, side. You have 2 angles, then a side, so that gives you angle, angle, side. And what's not here is side, 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 and we're about to prove side, side, side. So the steps in a formal proof starts with your given statement. Then you're gonna look at this, and we said we have a shared side. MO is congruent to MO. And whenever you see something congruent to itself, that is the reflexive property. And then we said that, well, then because of that, all 3 sides are congruent, so we can say that triangles are congruent by side, side, side. And then angle N is congruent to angle P. So once the triangles are congruent, all of their parts are congruent, all of their angles and all of their sides are congruent. So this abbreviation, CPCTC, just means that congruent parts of congruent triangles are congruent. And you'll see that a lot of times once you've proven a side that the angles are congruent. 11 is the same situation, so just follow that through. I said if, as far as memorizing this, I would focus on memorizing the one that's different and just understand the other two are the same. So perpendicular bisectors intersect at the circumcenter. So this point right here is called the circumcenter. And think about that. If I draw this circle that touches all the sides of this triangle, all the vertexes, that point will always be in the center of that circle. So think of circumference makes a circle, and the point is in the center. And that situation could be outside, inside, or on the triangle. All right, this is recent stuff. We talked about whether or not triangles are similar. So again, here we got parallel sides. Gives you alternate interior angles here and here. And then you have the third is a vertical angle. B, the only possible thing is side angle side. And then you have to check to see if the sides are proportional. And then the third one is side, 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 but check to see if they're proportion. So I'm going to set up a proportion small to small over big to big. And number 4, we only have an angle and a side, so we can't be similar there. Okay, so you want to be careful with this one. You've got the parallel line indicator, but you don't have parts. They didn't give you this, okay? And so we can't do just parts. So this one needs to be small triangle to big triangle. So we have to add up and get 6 plus x for the side, and then over 7. Set that up, solve the equation. And 15 is similar. Same idea. Small to big triangle. Then we have the shadow problem. Again, we're establishing similar triangles. These would be right angles, and if we have similar sides, then they're similar by side angle side. So 2 ways you could do height. You could think of it as height over shadow equals height over shadow. That's how I did that one. Or over, let's see, where did it go? This one is height over height equals shadow over shadow. As long as you're consistent, either one of those is going to work. Cross multiply and then solve. Okay, so on the first day of class, this is where we got to, so I think I'll stop this video here. So if you missed Tuesday, this is what we covered Tuesday, and I'll make another video for Wednesday's work. All right, talk to you later. Bye.